Hello everyone, this is my Physics 2 Lab 3 circuits. My name is Jerry Barra and this is my lab on circuits. For the introduction, the purpose is to see how batteries, capacitors, and resistors will react and interact with one another in a circuit, then predict the results of circuits when they have resistors in parallel and in series, and we used a multimeter to measure the real value of conventional currents and the potential differences in currents. And finally, it's to see the behavior of the ohmic resistors and capacitors. And for the results, in the first part, we had found that Kirchhoff's voltage law is true, and the sum of voltage in a loop will add to zero. Then in the second part, we found that increasing the resistance in the RC circuit will in turn increase the charging and discharging time of a capacitor. And these were the key principles, which were Kirchhoff's voltage law, Kirchhoff's current law, and Ohm's law. And Kirchhoff's voltage law says the sum of voltages in a loop will equal zero, and in the current law, it says total current entering equals total current leaving. And Ohm's law is the relationship between voltage, current, and resistance, which is V equals I times R. And for the experiment is to create different circuits and record various metrics using, which includes current and potential differences. And for the first one, we used two batteries, which were 1.5 volts, two resistors, 47 and 100 ohms, and two ammeters. And in part two, we used a 10 volt, and a 10 and 20 volt, 9 volt battery, and one capacitor. And the system was the closed circuit, and the surroundings were the earth and the air. And using Ohm laws, we calculate the current. This is a setup, and this was also the setup of our experiment. And this is my model for the potential differences. And for the ammeter is 0.1 volt, 47 ohm resistor was 0.897 volts, and the 100 ohm resistor was 1.902 volts. And the wire was 0.002 volts, which really is just 0 volts, and 2.9 volts is a sum. For calculating resistance, the resistance would be calculated using Ohm's law, where R equals V divided by I, and the resistance ammeter was 4.9 ohms, and the 47 ohm resistor was 93 ohms, while the 100 ohm resistor was 4.4 ohms, and the resistance wire was 0.10 ohms. And the ammeter in parallel, ammeter was placed in parallel to the 100 ohm resistor. The current was measured by the other ammeter and then increased by 53.6 milliamps. And because the ammeter has a very small resistance, this will then decrease the overall resistance of the resistor combination and lead this to more current being taken and drawn from the battery. And for the discharging and charging results, the 10 ohm resistor charging time was 15.88, and the discharging time was 16.35, and for the 20 ohm it was 28.88 for the charging, and the discharging time was 33.21. And when the resistance is greater than that, it means that there is less current flow. Then that means it will take longer for the capacitor to be fully charged and discharged. For the assumptions and errors, these are my assumptions and errors. Resistance of wires was negligible. Resistance of ammeter was negligible. Measurements could not have been as exact or precise, which is human error. Objects testing the circuit and potentially affecting results. Wire resistance was negligible and could cause difference with the ideal model. And the ideal model would have had some voltages in a loop equaling zero. If R equals zero and I would equal infinity, in turn would have the capacitor reach a full charge instantaneously because there's no resistance, but this wouldn't be possible. In real life, it would charge quicker, but it wouldn't be instantaneous because there will always be resistance present as no material has zero resistance. And thanks for watching my Lab 3 on circuits.